Here I'm going to talk you through the answers to the IGCSE higher paper from the 6th of June 2019. Question 1. We're being asked to work out estimate for the mean. So the first thing we do is we find the midpoint of these ranges here. So halfway between 90 and 100 is 95, halfway between 100 and 110 is 105, and so on. And from then onwards, we're just going to pretend these 8 sunflowers are exactly 95 centimetres high, and these 12 sunflowers are exactly 105 centimetres high, which of course they're not. They're somewhere in these ranges, but that's why it's an estimate for the mean. So the next thing you do is you cross multiply. You say 8 sunflowers are exactly 95 centimetres high. 8 times 95 is 760. 12 times 105 is 1260, and so on. You then add up these subtotals to get a total height of 5,400. Now be careful what you divide this by. This is the total height of the 48 sunflowers. So make sure you divide by 48, not by the number of rows, which is 5. That gives us 112.5, which must be your final answer. Do not round it because it says the word estimate. Okay, remember that estimating was to do with this assumption you made at the beginning. So make sure your final answer is 112.5. Question 2, we're being asked to use ruler and compasses to construct a perpendicular bisector. So bisector means the line's going to be halfway along between D and E, and perpendicular means it's got to be at 90 degrees to the line DE. So our final answer is going to be the red line. But we've got to use our ruler and compasses to do this. And the ruler isn't for measuring, the ruler is just for the straight line. So step 1, go and get your compass and put the point here at D, and then do a big arc over halfway, but less than all the way across. So you can see I've done that to here. So that's just a big arc that I've done from D. Then step 2, repeat with the same width of the compass, doing it from E. And those 2 blue lines are your workings. So your final answer, you now go and get your ruler out and place it so that the ruler is lining up with where my 2 blue lines cross. Fill that in, and that's your final answer. So question A, explain why A intersection B is this 0 sign. So A intersection B means the members that are in both A and in B. Now, if you look at A, you've got 2, 3, 5, 7. You look at B, you've got 4, 6, 8, 10. There aren't any numbers that are in both A and B. So that's your answer. There are no members which are in both A and B. Now, for part B, we're being asked for the numbers which are part of our universal set. So they're coming from the 1 to 10. So I've written down the numbers we're going to be selecting from. And then secondly, we're being told that X is not a member. This symbol here means not a member of A union B. Now, A union B means it's in A, or B, or both. So we're trying to exclude the ones that are in A or B or both. So I've gone and crossed off all the ones that are in A, which are 2, 3, 5, and 7. Crossed all the ones off that are in B, 4, 6, 8, and 10. And that's left me with only 1 and 9. So part C. Now I've begun by shading out this bit here because we know that A intersection B, there aren't any members. So that's why I've shaded out those. There aren't any numbers that are in both A and B. Next thing to note, please, A union B union C is our universe, the universal set. So all these numbers 1 to 10 are going to be in either A, B, or C. No numbers are going to be on the outside here. So the first thing I've done is taken to the fact that the A intersection C is 2. So the number that is in both A and C is 2. Now A intersection C is here. Now it can't be in this bit where A is intersecting with C, so that 2 has to be there. Next thing I've done is the bit in yellow. This means B, it's in both B and not in C. It's in B and not in C. So given that this bit is excluded, B and not in C has to be this area here. B not in C, so that's my 4, 6, and 10. Now, thirdly, I've then gone back to what should be in A, 2, 3, 5, and 7. Well, I know 2's here. Nothing's in these 2, so the 3, 5, and 7 has to be here. Fourthly, my bit in red. My B is 4, 6, 8 and 10. Nothing's here. 4, 6 and 10 are here. So my 8 has to be here. And then that just leaves me with the numbers 1 and 9. Now, they're not allowed to be on the outside because, as we said earlier on, they're in either A, B, or C. So the 1 and 9 has to be here. Now, I'm being asked to list all the members of set C. So that's the set C, this rugby ball here. So the numbers that are in C are 1, 2, 8, and 9. Question 4. Now we're being asked to work out the volume of this cylinder. Well, the volume of a cylinder is one of the given formulae. It's pi r squared h. So the area of the circle multiplied by the depth of the prism, the depth of the cylinder. Now the radius is half the diameter. So our radius is 7. So it's pi times 7 squared times the height, which is 20. Popping that into a calculator, we get this. Now rounding that to 3 significant figures, we get 3080. Question 5. We buy the 120 books for £4 each, so that's our costs. So 120 times £4 is 480. So that's all our costs. So we'll come back to that in a minute. Now, what about the income? What about the money coming in? Well, we sell half the books for £5 each. Well, half of 120 is 60. So we sell 60 books for £5 each, which is 300. Now, the green bit, we sell 40% of the books for £7 each. Now, 40% of 120, just do 0.4 times 120 on your calculator, is 48. So we sell 48 books at £7 each. 48 times 7 is 336. And then finally, with the rest of the books for £8 each. So we've got 12 books left over because that's the 120, take away 60, take away 48. So we sell 12 at £8 each, which is 96. Add up these three, we get total income of 732. So our income is 732, our costs are 480, so our profit, 732 take away 480 is £252. Now we're being asked for the percentage profit. Now your percentage profit is the profit divided by the original cost multiplied by 100%. So that's £252 profit divided by our original cost of 480 multiplied by 100%. That's 52.5%. B. So the book has increased by 20% in the last year. So I always like to set it out in these 3 columns. You've got the original price, the percentage change, and the final price. And we're told that it's gone up by 20%, 20 out of 100. So to help you get the multiplier, put 100 in the original column, always put that there. It's gone up by 20%, so 20 in the change column, and 100 add 20 is 120. Now, our multiplier to get from the original amount to the final amount, going left to right, is 120 divided by 100, which is 1.2. So to go from the original price to the final price, you would multiply by 1.2. But here, the way it's worded, we're going from the final price back to the original price. So rather than multiply by 1.2, we're going to divide by 1.2. Now, our final price is £15. Divide this by 1.2, giving us an original price of £12.50. Question 6. These are similar triangles. So the bigger one is proportionate to the smaller one. So each side is the same multiple of the original one. So look for the common side where you know the side on both shapes. So that's this left-hand side. We know it's 6 on the smaller shape and 15 on the bigger shape. So how many times bigger is that? Well, do 15 divided by 6 on your calculator and you get 2.5. So going left to right, all the sides are 2.5 times bigger. But going right to left, you would divide by 2.5 because everything's 2.5 times smaller. So to work out the length of DF here, well, it's going to be 4.2 multiplied by 2.5, which is 10.5. And then working out the length of BC, which is here, the smaller side, we take our 19.5, divide it by 2.5 to get 7.8. Question 7. Now, these questions come up a lot where you've been involving various means. And what you've got to do each time is to go back to the total number of students for each part of the question. So we're told that there are 30 students and the mean mark for these 30 students is 26.8. So the total marks for the students must be 30 times 26.8, which is 804. Now, we're much more familiar with doing it the other way. If I said to you that the total mark was 804 and there was 30 students, work out the mean, well, we would do 804 times 30 to get 26.8. This is just going the other way. So we've got 30 students with a total mark of 804. Now, we're told this about the boys in orange. There are 13 boys and their mean mark was 25. So their total mark, following the same methodology, is just 13 times 25, which is 325. So this is the total mark. This is the boys' mark. So if we take one away from the other, we get the girls' total of 479. So there are 17 girls, 30 take away 13. So the mean mark for the girls is going to be the total mark for the girls of 479 divided by the 17 girls, which is 28.176. To three significant figures, that is 28.2. Question 8. Now we're being asked here to change x kilometers per hour into a speed of meters per second. So we've got to go from kilometers per hour to meters per second. So I think it's best just to do this step by step. So a kilometer is how many meters? It's 1,000 meters. So to go from kilometers to meters, we're going to multiply by 1,000. So that's 1,000x meters per hour. Now, to go from hours to minutes, you're going to divide by 60. And from minutes to seconds, you're going to divide by 60 again. So converting this into meters per second is going to be our 1,000x divided by 60 and 60 again. So 1,000x over 60 times 60. Pop that 1,000 over 60 times 60 into your calculator. You get 5 over 18. So our final answer is 5x over 18. Question 9. Now we need to eliminate one of our variables. We need to eliminate either x or y. Now I've called these equations 1 and equation 2. Now I could have just taken equation 2 and doubled it to get minus 2y, then added them together. That would allow me to eliminate the y's, and that's absolutely fine. But I'm going to choose to eliminate the x's. So I've got 3x in equation 2. In order to get 3x in equation 1, I'm going to have to multiply each term by 3. So multiplying each term by 3, I get 3x plus 6y minus 1.5. So that's my, so here I have my equation 1 once I've multiplied it by 3. Now line up equation 2 underneath it. 3x minus y equals 16. I've then got to make a decision whether to add or subtract these equations from each other. Now, if I was to add them, I'd just get 6x here, which isn't eliminating x. So I don't want to add them. I want to subtract the two equations. So 3x take away 3x is nothing. That's the whole point. I've eliminated x. 6y minus y. Sorry, ignore the bell. 6y minus y is 6y add y, which is 7y. And then minus 1.5 minus 16 is minus 17.5. So here I've got an equation I can solve. I've just got the one variable. 7y equals minus 17.5. So divide both sides by 7. I get y being minus 2.5. So that's part of my final answer, y being minus 2.5. Now I need to go and work out what x is. So I take my known y value and I substitute it back into either of the two original equations. It doesn't matter which one. I've decided to substitute it into equation 1. So here's my equation 1 again. I'm replacing the y with minus 2.5 here. Now 2 lots of minus 2.5 is minus 5. Add 5 to both sides, I get x being 4.5. Question 10. Write down an equation for L. Now remember your starting point should be y equals mx plus c for any straight line, where m is the gradient and c is where the line crosses the y-axis. Now we're told the gradient is 5, so m is 5, and we're told the line crosses the y-axis at 0, minus 3, so our y-intercept is minus 3. So our answer is y equals 5x minus 3. Now for part B, let's just first of all work out what each of the 4 lines are that surround this square, which make up the square. So let's do this one first here, going vertically down through 2. This is the line when x always equals 2. So be careful. It's not y equaling 2. I know it's parallel to the y-axis, but it's not y being 2. All the points on this line, all the coordinates here, would have an x value of 2. 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. So this line is the set of points where x equals 2. Equally, this vertical line through 0 is x equaling 0. And therefore, horizontally, this is the set of points when y equals 1 and y equals 3. So those are the boundaries of our field, if you like. They're the fences. So that region R, the area inside those 4 fences, well, it's between 0 and 2 for the x values. And because these lines are solid, it actually includes the fences themselves. So it's going to include the equal signs each time. So the region R is less than or equal to 2, but greater than or equal to 0. You remember with this type of inequality, you read it from the middle, you read it from the x. So this reads x is less than or equal to 2, which is kind of obvious, but here you've got to read it right to left. This is x being greater than or equal to 0. So make sure these inequalities are pointing in the same direction, if you like, both pointing to the left. And similarly with the horizontal lines, the region R is between 1 and 3. It's greater than or equal to 1, less than or equal to 3, which is what we've written here. Greater than or equal to 1, reading it from the centre, but less than or equal to 3. Question 11. Part A, find the difference between the average crowd attendance for Barcelona and Monaco. So Barcelona is 7.7 times 10 to the 4, and Monaco is 9.5 times 10 to the 3. So obviously the difference, you just take one away from the other. So I just simply pop that into your calculator. That gives you 67,500. Now they're asking for the answer in standard form. So just to remind you how to do this, in standard form, the first number's got to be between 1 and 10. So the decimal point's going to have to be between the 6 and the 7. So 6.75. And then times 10 to the power, and the power is going to be positive because this is a big number. Then just think of the decimal point hopping along. The decimal point is starting after the 500. It needs to finish between the 6 and the 7. So that's 1, 2, 3, 4 hops. 6.75 times 10 to the 4. Part B, the average crowd attendance for Chelsea is approximately 50 times that for Oxford United. So take the Chelsea crowd, divide it by the Oxford crowd, and we get 5.06. So it's approximately 5 times bigger, not 50. So Antonio is not correct. It's approximately 5 times bigger. Part C. We start off with a 15% increase. So that's going to be a multiplier of 1.15. But we then have a decrease by 8%. So it's coming down 8% from 100%. 100% take away 8% is 92%. So that's going to be a multiplier of 0.92. Now get your calculator out and multiply both of these together. And we get a net multiplier of 1.058. So the actual percentage increase is 5.8%. Question 12, we're being asked to work out the perimeter of this trapezium. That means the length all the way around the shape. So in order to do that, we're going to need to know this length here, which is obviously 21.2, and this length here, which I'm calling y, and this length here, which I'm calling x, and then we can just add up all these lengths on the outside. Now, starting off with working out x, this is 43 degrees, obviously. This dotted line here, which doesn't form part of the perimeter, but I need it for my calculation. Obviously, that length is 16.7, because it's opposite here. So looking at this triangle here, to work out x, this side is opposite me. This is the hypotenuse, so I'm going to be using sin. Sin is opposite over hypotenuse. So sin 43 equals my opposite side of 16.7 divided by my hypotenuse of x. So rearranging this, you've got to be careful when it's the unknown on the bottom. Multiply by x and then divide by sin 43. So 2 stages of algebra takes us to here. So x is going to be 16.7 divided by sin 43, which is 24.486 ... Now, to work out y, again using angle 43, the 16.7 is opposite, the y is adjacent, so this is tan being opposite over adjacent. So tan 43 equals my opposite of 16.7 divided by my adjacent of y. Multiply both sides by y, divide both sides by tan 43, we get y being 16.7 over tan 43. Pop that into your calculator, you get 17.9085. So then run around the shape adding up all the sides. Okay, so we've got 16.7, we've got 21.2, we've got x of 24.486, we've got 17.989805. So all our sides around the outside, add them all together, we get 101. Right, finally got that to stop it. Okay, so we get 101.49, round that to 3 significant figures, we get 101. Okay, so 21.2, 24.486, 70.9805, 21.2, 16.7, 101.49, 101 when it's rounded to 3 sig figs. 13 part A, complete the cumulative frequency table. Now note how all these start off at 0. So we're trying to work out the frequency, the total number of taxi journeys between 0 and 5, or 0 and 10, or 0 and 15. Now 0 to 5 is obviously just the 7. It's just copied from this table. Now 0 to 10 is those that are 0 to 5 or 5 to 10. So it's adding up the two top values, which is 7 and 10, which is 17. Now 0 to 15 is 0 to 5 or 5 to 10 or 10 to 15. So we add up the top 3. Okay, so as we fill in the table, we just keep on adding the next number. So 7, then 7 add 10 is 17, add the 12 to get 29, add the 19 to get 48, and so on. Now for part B, when you plot a cumulative frequency graph, please remember to make your x-coordinate the upper bound. So we're going to be plotting 5, 7 and 10, 17 and so on, which I've plotted over here in blue, and then make it a nice gentle curve, and you'll always find you get this sort of falling over S. Now part C, use your graph to find an estimate for the median. Now the median is the middle one. Half of 80 taxi journeys is 40. So here's our 40th taxi journey. So get your ruler out, draw a line across, hit your curve, go down and take a reading, and I got 18. Now there's a little bit of leeway with the marking. Anything between 17 to 19 would have given you the mark. Now use your graph to find an estimate for the interquartile range. Now this is the range between the quarter value and the 3/4 value. Now a quarter of 80 is 20. So here's my 20 in red. Go and take a reading. I've got 11.5. Now 3/4 of 80, 3 lots of 20 is 60. So go along, hit your curve with a horizontal line using your ruler. Go down and take a reading. I've got 23. Now your interquartile range is the difference between the lower quartile and the upper quartile. So for me, it's 23 take away 11.5, which was 11.5. Again, the mark scheme allows some leeway because everybody's curve is going to be a little bit different as it's drawn by hand. The mark scheme allowed anything between 9 to 13, providing it was backed up by your diagram. Question 14. Now, I always find a diagram just helps me gather my thoughts. So going from A to B, I'm going 6 to the right and 9 down. So A to B, 6 to the right, 9 down. It doesn't have to be to scale, just make sure you're going in the right direction. Now, going from C to B is 1 across and 3 up. So C to B is 1 across and 3 up. And I'm being asked to work out the magnitude of A to C. So the size of this vector if you're going in a straight line from A to C. Now, how do I get from A to C? I go A to B, then B to C. A to B, then B to C. Now, my A to B is obviously 6 minus 9. But my B to C is the opposite of my C to B. So rather than being 1, 3, rather than 1 across and 3 up, which C to B was, I'm going B to C. So that's 1 to the left and 3 down. So minus 1, minus 3. So adding these two vectors together, I get AC being 5 minus 12. Now 6 take away 1 is 5, minus 9, minus 3 is minus 12. Now that would be fine if we were being asked for the vector AC, but we're being asked for the magnitude of AC. That means the actual size going directly from A to C. So for that, we go and use Pythagoras. Okay, we've got the vector going from A to C, which is 5 across and minus 12 down. Just picture this, 5 across, minus 12 down. We want this diagonal here, so it's going to be, we just Pythagoras our two coordinates. So it's 5 squared plus minus 12 squared, and then we square root that answer. So we've got 25 at 144, 169, square root that, you get 13. So the magnitude of AC, this length here, is 13. Question 15, we're being asked to make x equal the subject. So we've got to move away from y equaling something to x equaling something. So the first thing I'm going to undo is undo the square root. So I'm going to square both sides. So y squared equals 3x minus 2 all over x plus 1. You have to do that first because everything's tied up and being square rooted. Now, because my next step, I want to undo having a fraction. I want to get everything onto one level. So to undo dividing by x plus 1, I'm going to multiply both sides by x plus 1, giving me this. I'm now going to multiply out my bracket. So y squared times x is xy squared. Y squared times 1 is y squared. Now, my next step, I want to get all the terms which include x's on one side and all the terms that don't include x's on the other. Now, I'm going to choose to take everything with x's to the right-hand side just to keep everything as positive as I can. If I take it all to the left-hand side, or the x's to the left-hand side, I'm going to get lots of minuses in my answer that just isn't really very eloquent. So I'm going to go and take all my x's to the right-hand side. So to undo plus xy squared here, I'm taking away xy squared from both sides. And to undo this minus 2, I've added 2 to both sides. So on this line here, you can see the terms on the left do not include x's. The terms on the right all include x's. Now, once I've done that, this is the clever bit. I can now go and factorize my right-hand side. So 3x minus xy squared becomes x bracket 3 minus y squared. And for the first time, I've now only got x cropping up once in the equation. Okay, twice here, twice here, twice here, and so on. So I'm nearly there now. So once I've factorized, I've got x times the bracket. I want x on its own, so I just undo the timesing by the bracket by dividing both sides by the bracket. Okay, so I'm then left with x equaling y squared plus 2 all over 3 minus y squared. I don't need the bracket anymore, so I've just lost the bracket at that point. And that's my final answer, x equaling y squared, x equaling y squared plus 2 over 3 minus y squared. Whoops. What I should have actually done, I'll just pop it in now. This should say x equals. Okay, whoops, excuse the handwriting. This should definitely be saying x equals. Right, I often have this problem. Let's just get this up. Whoops. There we go. Now I can stop it. Question 16. Now we're being asked to rewrite this in this format. So we've got to rationalize this third. We need to get rid of it. We get rid of the denominator. Now, learning point. The key bit here is you're going to choose to multiply top and bottom by the denominator, but with a change of sign, and I'll explain why in a minute. So rather than multiplying both sides by root 2 minus 1, we're going to multiply top and bottom by root 2 plus 1. So that bit in purple is the key learning point. So we've now just got pairs of brackets to multiply out. So 4 times root 2 is 4 root 2. 4 times 1 is 4. Root 8 times root 2 is root 16. And root 8 times 1 is root 8. That's a 4 clause in the numerator. And on the bottom, root 2 times root 2 is root 4, which is 2. Root 2 times 1 is root 2. Minus 1 times root 2 is minus root 2. Minus 1 times 1 is minus 1. Now, this is the key bit, okay? Because we've had that change of sign, these two middle terms here will always cancel out. Okay, because we had this change of sign here. Rather than minus 1, we've got the plus 1. So we're now left on the denominator with just the 2 taking away the 1, which will become 1 in a minute. Now, and in the numerator, I've just simplified it here. I've got, obviously, root 16 is 4. And then I can see that I'm aiming for an answer that's just got root 2's in it. So I've taken this opportunity now to simplify root 8. Now, remember, root 8 is root 4 times root 2. Root 4 is 2, so that's 2 root 2. So make sure you're comfortable that root 8 is 2 root 2. So tidying everything up, 4 lots of root 2, add 2 lots of root 2 is 6 lots of root 2. 4 add 4 is 8. 2 take away 1 is obviously 1. So our final answer is 8 plus 6 root 2. (17a). So we start off being told y is directly proportional to the cube of x. So that's what I've popped into an equation here. So y equals kx cubed. So because it was directly proportional, it's k times x cubed. Had it been inversely proportional, it would have been k over x cubed. So y equals kx cubed has come from that top sentence. Now, on the second sentence, I'm told that y equals 20h. Okay, so 20h equals kh cubed, because we've been told that y equals 20h. So at that point, I can divide through by h. So 20 equals kh squared. Dividing by h squared, I get k equaling 20 over h squared. Now, I'm being asked to find a final formula for y in terms of x and h. So I don't want k involved. So I'm going to take this equation here, which I'm calling equation 1, and substituting it back into this equation here that I'm calling equation 2. So I'm replacing the k with 20h squared. So y equals 20 over h squared times x cubed. So final answer, 20x cubed over h squared. Part B, we're now being told to find x in terms of h and y equals 67.5h. So I'm replacing my y here with 67.5h, and that's equaling 20x cubed over h squared. Okay, just taken my answer to part A, replace the y with 67.5h, and I'm just going to manipulate this to make x the subject. So to undo the dividing by h squared, I've multiplied by h squared. I've then divided by 20, putting 67.5 divided by 20 into my calculator, I got 27 over 8. And then to undo this cubing, I'm cube rooting both sides. Now the cube root of 27 over 8, again, you can do it on your calculator, but the cube root of 27 is 3, cube root of 8 is 2, so that's 3 over 2. And the cube root of h cubed is just h, okay? So that's our final answer is 3 over 2h. Question 18. So we're being asked to find the maximum value of A, and the total surface area of the cuboid is A. So we're being asked to find the maximum surface area. So first of all, step 1, we're going to have to work out the surface area in terms of A, in terms of x, excuse me. So the top and the bottom are x times x, so we've got a couple of those. So that's 2 lots of x squared. And then the 4 sides, we've got 4 of them, are going to be x times 12 minus 3x. So that's my first line of workings. So processing that algebra, just work your way through those lines, you get to a total surface area of 48x minus 10x squared. Now, there's two ways you can then work out the maximum value. You can either use the blue method I've used over here of differentiating, and I think that's quicker. But if you're not comfortable with differentiating it, you could do this purple method by completing the square. So if I were you, I'd just work through both and then just decide which one you would be more comfortable with. So differentiating this, the blue one first, when we differentiate 48x, we get 48. When we differentiate minus 10x squared, we get minus 20x. Remember, you multiply by the current power, reduce the power by 1. Now, at a maximum or a minimum, the differential equals 0. So we set this equal to 0. We set our 48 minus 20x to 0. Add 20x to both sides, divide by 20. We get x being 2.4. Now, what surface area do we get when x is 2.4? I've taken my 2.4 and substituted it back into this surface area equation, giving me 57.6. So that's my final answer. Now, doing it the purple, completing the square method. So we've got minus 10x squared plus 48x. Now, to complete the square, we need a single x squared. So I've taken my minus 10 outside, leaving me with x squared minus 4.8x. Completing the square on that, I get x minus 2.4 all squared minus 5.76. So I can see there to get this at a maximum. To get this at a maximum, given I'm multiplying by minus 10, I want the inside to be the biggest possible maximum. I need this to be 0. In short, I need this to be 0. So again, my x value is going to be 2.4. And just like above, you then substitute that back into the surface area equation to get 57.6. So I think the differentiating method is easier, but you could have done this by completing the square if you prefer. Question 19. So we've been told that the area of the triangle ACD is 250. So that's going to allow us to work out the length AC. Okay, an area of a triangle is half AB sin C. So we can say that the area of this triangle ACD is going to be half times AC times 26 times sin 39, and that area being 250. So that's my first line there in red. So processing that algebra, I get the length AC being 30.55799. Now, moving over to triangle ABC, I can use the sine rule. So I've started off by just working out this angle at the top, angle A, by angles in a triangle adding up to 180. So that's 38. So I've got a pair now. I've got a pair. I've got my 95 and my 38. So given I know the 47, I can now work out the AB. So AB over sin 47, that pair there, equals 30.557, my AC, over sin 95. So AB over sin 47 equals AC, which I've worked out that 30.557 over sin 95, which I've got here in purple. Multiplying both sides by sin 47, I can work out that AB equals 22.434. So I'm now able to work out the area of triangle ABC, again using the area of a triangle rule. Half times AB times AC times sin 38 is going to equal the area of this triangle. So half of the 22.4 times the 30.55 times sin 38. Add those together, I get 211.02 dot dot dot. So the area of the whole quadrilateral is adding the two triangles together is my 211.02 added together with the 250, giving me 461.02 dot dot dot. Three significant figures, that's 461. Question 20. They intersect at 2 points, the line and the curve, find these points. So where they intersect, they are equal to each other. The x values are equal, the y values are equal. So I can go and substitute my L equation, 9 minus x. I can go and substitute this in to replace the y's in the curve, equation C. Okay, they are equal to each other, so they're equal to each other. So I can just replace the y with what it is equal to, which is the 9 minus x. So I've just copied out equation C here, and whenever I've got a y, I've replaced it with 9 minus x. So I then just process that algebra. So I've kicked off by doing minus 3x times 9 minus 3x times minus x to get these two terms. And then I've done this pair of brackets. I've done 9 minus x times 9 minus x, giving me this here. I've then gone and done the claw here. I've just multiplied out, expanded this bracket here, giving me this line here. And then I've tidied it all up. I've simplified like terms here. And I could see it was all divisible by 3. So I've divided it by 3, giving me this equation here. So my A is 2, my B is minus 21, my C is 54. And I've substituted that into the quadratic equation, giving me x values of 6 and 4.5. I've then just used the fact that y equals 9 minus x with these x values to work out my y values being 3 and 4.5. Question 21. Well, not actually given any lengths here, but we're given the ratio between lengths, and given we're going to be working out an angle, the ratio is all we need. So I'm just going to treat these three as the lengths. So I'm going to say the length of AB is 4, the length of BC is 2, and the length of CF is 3. So I've popped those onto my diagram. Now, the trickiest bit with this question is understanding what they're asking for. They're asking for the size of the angle between AF, which is this line here, and the plane ABCD, which is obviously a two-dimensional shape. It's the base. So you've just got to imagine cutting down through, slicing through the cuboid. As you went down from AF in a straight line, your knife would get to here. So you're really cutting down to getting to here. So the actual angle we want is this angle here in triangle A to F to C. So just hook out that triangle to gather your thoughts. A to F to C, and the angle we require I'm calling X here. Now we know the length F to C is 3, but we don't know anything else yet. But I can work out the length AC if I look at the right angled triangle A to B to C. So again, hook out the right angled triangle A to B to C. Once it's two-dimensional, it's much easier to see. The length from A to B is 4, from B to C is 2. So using Pythagoras, we can work out that the length from A to C is root 20. Okay, A squared plus B squared equals C squared. So I've taken my root 20 over to this diagram here. So I know my opposite side is 3, my adjacent side is root 20, opposite over adjacent is tan. So tan x equals 3 over root 20. So x equals inverse tan 3 over root 20. Pop that into your calculator, round it to one decimal place, you get 33.9. So to simplify question 22, we need to do lots of factorising. So I've hooked out the numerator over here, 6x squared plus 13x minus 5. And then I'm going to talk you through the method I do. So it's quite a complicated method, but it's sort of slow and steady wins the race, really. So I'm looking for two magic numbers that multiply to be 6 times minus 5, which is minus 30, but add to be the coefficient of x, which is 13. So that's 5 and minus 2. Now, step 2, I move away from having 3 terms to 4 terms. I split this plus 13x down into 15 and minus 2. Doesn't matter which way around, but that's what I've done here. So I've actually made things look a bit more difficult. I've gone from 3 terms to 4 terms. Line 3, I fully factorised terms 1 and 2, and I fully factorised terms 3 and 4. So 6x squared plus 15x is 3x and 2x plus 5 in a bracket. And minus 2x minus 5 is this. Now, you just got to fiddle around with this factorising of terms 3 and 4 a bit, because you do want to have a repeated bracket. That's why I've gone for the minus 1 here rather than plus 1. And then your final line, the two brackets comprise the two components that are here and here, the 3x minus 1 and your repeated bracket, which is 2x plus 5. So that's my numerator. Now, with the denominator, you've just got to spot that this is the difference between two squares. Okay, this is a square number taking away another square number. So 4x squared minus 25 becomes 2x plus 5, 2x minus 5. Okay. Oh, I forgot to say right at the beginning, sorry, I should have said. To start off with, I just took out the x. Okay, I took out the x. I factorized taking out the x, giving me the 6x squared plus 13x minus 5. And that's what I did the side working on. Sorry, I forgot that. Okay, so I noticed there was an x in each term, so I factorized taking out the x. And then what I was explaining earlier on, that was factorizing the quadratic. So I get to this point here. Oh, in fact, I get to this point here. Now my 2x plus 5 and my 2x plus 5 cancel out, leaving a final answer of x 3x minus 1 all over 2x minus 5. Question 23. Now this is a really difficult question. I'd have hated to try to do this under exam conditions. So just try and bear with me, but if you don't really understand this question, it's not the end of the world. These are really difficult marks. So I think our entry point here is that there were originally 3 red sweets in the bag. So the number of red sweets is 3. Now we don't know the total number of sweets, but let's just call it X. So if there's X number of sweets and 3 of them are red, we would have started off with the green being X take away 3. Right, that sort of makes sense, doesn't it? It's going to be the number of green is going to be 3 less than whatever X is. Okay, so let's just go and do a little tree diagram over here. And so picking a red, then a red, then a red, then a green, then a red, green, and a green. And we're told that the probability takes exactly 1 red sweet. So just 1 is 12 over 35. So these two endpoints here and here, the red, green, green, red, those added together have got to be 12 over 35. They'll equal 12 over 35. So how do we get to these 2 points here and here? We either go red, green, or we go green, red. So let's consider the red, green first of all. The probability of a red with our first pick is 3 out of x. Fair enough. And then if we were to get a green with our second pick, now you've got to really think here, the number of greens hasn't changed because we picked a red first of all. So the number of greens, the numerator, is x minus 3. But our denominator, our total, has gone down by 1 because we've picked a red. So our denominator is going to be x minus 1. So to end up with red-green, it's this times this. 3 over x times x minus 3 over x minus 1. So let's just park that. That there is getting red-green. Now, what about green-red? Now, getting a green with our first pick, that's fair enough. That's x minus 3 out of x. And then getting a red with our second pick, well, we've still got 3 reds because we picked a green first of all. And our total is now x minus 1. We've gone down 1 because we've gone and picked a green. So green-red is this times this. X minus 3 over x times 3 over x minus 1. So we know this red-green plus green-red has to equal our total of 12 over 35, which we were given. So we just then need to multiply out. So I've gone and multiplied everything by x times x minus 1. Okay, so just multiplying through by x over x minus 1 gives us this line here. So that's just getting rid of the denominators. Then I've expanded my brackets. What have I done? I've then gathered like terms on the left. And then I have, what else? Then at that point, I can see that 6, 18, and 12 divide by 6. So I've divided 3 by 6. And then to get rid of this dividing by 35, I've multiplied the left-hand side by 35. And I've multiplied the right-hand side by the 2, giving me this line here. Formed that into a quadratic, which I've then factorized here. Now, my two solutions are 3 over 2 and 15. Well, x is a number, isn't it? It's a number of, it's a total number of sweets. So x can't be a fraction, so my answer must be x being 15. Now the question asks how many greens were there originally. So if there was 15 sweets originally, 15 minus 3 equals 12 green sweets. So just to repeat, that's extremely difficult. There's lots of skills going on there. It was worth 5 marks, but if you're struggling with this one, I really wouldn't lose sleep over it. It was really, really difficult. I have skirted over how to factorize one of these trickier quadratics. If you want a more detailed view of how to do that, go back and look at question 22 on the right-hand side. Okay, I've just haven't sort of repeated the process again. There was an alternative approach to doing question 3. It was slightly different. It was just if you decided to call the number of x's, you decided to call x the number of greens and then the total 3 plus x. So that was an alternative way of doing the algebra. It's a very similar method, but if your starting assumption was to say let the number of greens be x, so our total being 3 plus x, I've just got the solution here explaining how that works. So obviously you get the same answer of 12, but it was just an alternative approach to it. So it doesn't matter which method you've used, whether you've let the green x be the number of greens or x be the total. Question 24. Now this one was a bit bizarre because part A was almost one of the easiest questions on the paper. And I think if you weren't confident, you might think that you've missed something because could it be that easy? But it was. F of 5, you just literally substitute 5 into the function. So 3 lots of 5 take away 2 is 13. So that's 1 mark on the last question on the paper already. Now for part B, to find the inverse function, sorry about that. To find the inverse function, we're going to have to change the subject, and you can't do that while you've got x cropping up twice in the equation. So you had to remember that you could complete the square. So we kick off by completing the square here. So we take out the 2 to give us a single x squared. So we factorize taking out the 2, and we've then completed the square on inside these square brackets, taking us down to here, and then I've multiplied by the 2 again. So I've got g of x in this format here. So I can change the subject on this because x is only cropping up once. So let y equal this function. I've then added 41. I've then divided by 2. I've then square rooted, and then I've added 5. Now remember, y is just something we've artificially introduced to let us change the subject. So our final answer, we're going to replace the y with an x. So our inverse function for g is 5 plus the square root of x plus 41 over 2.